Hey, it's Steve with PageKey Tech. Welcome back for the 15th episode of our PKOS series where we're building an operating system. In this video, we're talking about VGA. Okay, let's check it out. The full write-up is at pagekeytech.com, so we'll just be summarizing that write-up in this video. So we'll start with a demo of what we're actually going to be doing, what the code does, emulated and real hardware. Then we'll summarize the write-up that's at pagekeytech.com, go through each section and talk about what we learned. If you want to know the references, I did cite my sources, just posted the links where I read about these various topics. Just check out the link. So here's the first demo using QEMU. If you want to follow along, clone the repository, check out the commit for this, and then you might have to do exos local root on Ubuntu or Mac, probably not on Windows. And then we can do docker compose up, and we get our little PCOS, just like we had before. You can do ls, you can do help, and finally we have VGA. And we'll pop into VGA mode and we see some faces, some colors. Here's the second demo using some real hardware, an actual laptop. So here we have the lovely HP Pavilion DM4 with an i5 processor, truly aged to perfection. And on this USB drive, we have PKOS. We used the ISO build and put her on there, and we should be good to go. Note that this is a BIOS machine. I tried it on my current laptop and it didn't even recognize this as a bootable device, I think because it's UEFI, whereas this image expects, BIOS. I don't know, I could be wrong, but either way it doesn't work on new stuff for some reason. So if we hit the escape key, go for the generic flash disk, Grub does its thing, we can hit enter, and here we go. Legit, bare metal kind of solution. And we'll go VGA, and there it is, just like the emulated one. A little background on VGA. VGA stands for Video Graphics Array, and it's a pretty old format for CRT monitors. So VGA chipsets were operating with analog signals and not digital, and DVI, digital video interface, largely replaced VGA. And I'm sure you've heard of HDMI, high definition multimedia interface. Turns out that that's largely the same as DVI. It just has more color depth and includes audio, all bundled into that one little cable. So since the last video, I got a little curious and looked up the man page for the QEMU i386 emulator that we're using for this operating system, for most of our testing at least. And it tells you actually exactly what types of hardware are attached, the exact models for most of this stuff. And I thought that was pretty cool, and it could maybe guide some development. If we want to do floppy disk stuff, we can do that or whatever. But of course the big one on here is the Cirrus CLGD PCI VGA card or dummy VGA card with botched FASA extensions, whatever. I tried to look this card up, and it is old enough that there's a museum type page of it, but nowhere to really buy it on Amazon or something like that if you wanted to actually purchase that chipset in a physical device. So I think it's either emulated or included right on the motherboard, who knows. So VGA Hardware, a not so encouraging quote that I ran across was, while the VGA chip is quite a simple piece of hardware, it's possibly one of the most complicated devices to program for. So if that doesn't scare you off, it's perfect. So VGA Hardware, it's a good way to get started with video drivers on the bright side. And I found a snippet of code to use as a sample. It was a really large C file on the OS Dev Wiki. And basically there's two things that we have to do to get the VGA working, or at least the route that I went was you use I/O ports to communicate with the VGA chips or chipset or whatever it is, and set the display mode, and then you use memory mapped I/O to plot the pixels. The memory mapped I/O should be familiar if you followed the rest of the videos, because we used that to put text on the screen. So it's the same deal here, just the complicated part is the I/O ports that are communicating with the hardware. And I took this little diagram from the OS Dev Wiki as well, and it shows a diagram of VGA hardware. And I thought an interesting tidbit was that there's a sequencer that is outside of our realm of control, and it's attached to the video memory, and that is the thing that reads the colors and generates those colors and sends them to the rest of the system. So there's something plugged into the memory that we're modifying that's reading it and, doing whatever it has to do with it. We don't have to really worry about it. Something that I wanted to do was to set the graphics mode without the BIOS. So you can always drop back into real mode and use the BIOS if you wanted to, but I'm saying we're in protected mode. We're going to leave that in the dust and do it ourselves somehow on bare metal without the aid of the BIOS or anything else. And another encouraging quote was, how do you do this? You don't. Graphics programming is fun, but not essential for an OS, so don't get sidetracked. I'm sure that came from a true veteran who's been there. So knowing that, I didn't take this too far, but I did learn a few things. So you can make VGA work without the BIOS for some low resolution graphics. And beyond that, another quote, unless you have more than one life to waste, don't go further than that. Each graphics card is going to need its own implementation of a driver, and a lot of cards don't have enough documentation available to the public to write that driver. On the bright side, I would think that drivers would be available, and maybe you can port them to your OS, to your own little tool chain if you have it, but even that would be a big effort. So I guess we're just dipping our toes and calling it a day. Either way, we can walk through the code, the difference from the last OS to this one, and see what changed. So code differences since the last video, only a few changed files, the make file and Docker, the top stuff here is just cleanup. And the main meat of it is in VGA.h and VGA.c. But as you can see in kernel, we tie it in for one of our commands when you type VGA, like we already have help and ls and all that stuff. Before it said not implemented, now it says VGA test. Where is that pointing? VGA.h, if we go in here, we have a lot of stuff. The most important one being VGA test here, which is what it's calling. And we also have clear screen, plot pixel, and as you can see, I say start and end copied code. All of these variables come from that snippet, which here's the link to that snippet. And one issue I ran into was the VGA address was wrong. I had too many zeros here. So it's A followed by 4 zeros. And that actually lets us draw on the screen. In the actual C file, we define the colors, which are, as far as I know, a short, so only one little byte. And this should be in the copied code section as well, because this came straight from that snippet. And in VGA test, all we're doing is attempting to switch modes, writing the registers. So we're taking this variable, which is just a list of characters, and writing the registers. There's also a method that I copied that does that using in and out bytes. So this is the IO port part rather than memory mapped IO. Then we clear screen, which I wrote, and we draw a rectangle, draw a happy face, plot some random pixels. We iterate through the colors, and that's it. The core of this is the plot pixel, where we take an X and a Y and a color. We calculate the offset, which is just whatever X value plus the number of pixels in a row times Y. And then we create a pointer to VGA address, and we can use the array notation to set that many bytes into that character array to our color. So really we're just calculating the exact byte in memory we need to change and modifying the color value. And down here we have a lot of copied code that I don't entirely understand. Okay, I really don't understand it at all, but it works and it's pretty cool. So thanks to the person who wrote this. Clearing the screen, we're really just plotting color black on all the pixels. So once we have this plot pixel function, we can do just about anything. So we can clear the screen one pixel at a time. We can draw a happy face, which is just a bunch of pixels. We can draw a rectangle given X, Y, width and height. It's just a loop of changing pixels. And our test is just, using these methods. So it gives me kind of an appreciation for things like OpenGL and all that stuff. This could not be further from those things, but still, it makes it make sense where you have a pipeline of some abstraction in memory, and then you're mapping it further and further down that pipeline until eventually you're finally writing actual pixel data. So you're performing all of those calculations maybe on a GPU or whatever, all these matrix math projections and things that I know happen somewhere in OpenGL. And eventually you end up with an array of pixels, but it might start somewhere smaller or larger or whatever. So it's kind of cool to see. And then of course there's just a make file. It's quite like all the others. We went through the kernel.c and just a couple little Docker helper scripts and tweaks to the make file, but that's pretty much the bulk of the code that we changed. So one issue with this, the glaring issue, is that once you're in VGA mode, you're kind of stuck there. The only way to get out of it is to reboot the system. And that's not really cool. It would be nice to hit a key and get out of it, but I tried and I couldn't figure out how to do that. Our helpful code sample that got us into VGA mode, and I mostly copied code for this one from that code sample. To get back into text mode, it uses some things that aren't available in that snippet, dos.h or memcpy, some things that are dependent on which compiler you have. I tried a quick disgusting implementation of memcpy, and it was probably quite subpar. Either way, I couldn't get past a plain black screen. So when I hit the escape key on my code, it would just clear the screen and no text would come out. So I don't know what I did wrong. I think I had to copy the font or something, but I wasn't able to do it. Needed virtual memory. I don't know. It got very complicated. What I tried was adding a key code check for number 1, which in our key map is the escape key, at which point we say VGA enter text mode. We copied in some things from that file, right font, some more of these things that I had hoped would help. The font and the text mode registers dump, and note that the font is 4096 bytes, which is why it's not showing us this diff. But if we load that, I tried all kinds of stuff here, and I couldn't make it happen. So can't win them all, I suppose. Yeah, it's poking bytes into memory, which is all good, but it gets into this vmem write. So I'm assuming virtual memory write, and it needs a mem copy of this and that and the other thing. Also, that was enclosed in these compiler tags, so there were different ways of implementing this vmemWrite function, and it got well beyond my understanding. Like, I just don't even know what to do with any of this stuff. So maybe next time. If you know, let me know. Other quick lessons learned, more general, added script / docker run debug. So trying to have a script for everything you can do, or so that you don't have to type raw docker or docker compose commands. It just wraps the make run debug so that you can use it directly, like with QEMU and all that stuff. Extern for global variables. I didn't know about that one. If you have a global variable in your header file, you don't want to put the value in the header file because it ends up getting defined in multiple places. The compiler will yell at you for that. So you declare it as extern in the header file, and then you give it the actual value in your .c file. And then header guards, I was forgetting some of those too, which gave all kinds of errors. So those two are probably just C newbie mistakes, but I don't have a lot of C experience, so I'm getting it now. And that's really it for this one. Thanks for watching, and let me know if you have ideas for other ones or any of that stuff. Appreciate you watching.